Hello everyone, this is How I Love Geometry. I'm Mr. Chao. Triangle ABC, right? PS parallel to AB, UR parallel to PC, TQ parallel to AC, and all of these three segments pass through the same point X. So the problem led us to prove PQ over BC. We see PQ over BC and RS over CA, TU over AB. The sum of all these three ratios equals 1. And the second part let us to find the area of ABC. Use A, B, C to represent the area of triangle ABC. A is the area of small triangle TUX, and B is the SRX, and C is the area of triangle PQX. So when we know a lot of parallel lines or parallel segments, what we can say, what we can think about? Of course, the first idea will be the similar triangle. And here we find also find a lot of parallelogram, right? Because the parallels, right? And here, parallel to this. And we know a lot of parallel lines, right? So the parallel lines we will think about is the similar triangle. Similar triangle will got the ratio of the corresponding sides. So the first problem is just about that. So we will use this idea to try. The second part is about the area. Because we have a lot of similar triangles, we know on the same plane, the similar shapes, the corresponding size ratio, when we square them, it will be the ratio of the corresponding area. So we can also try this idea to find the answer of the second part. Okay, let's go. First one, here we see PQ over BC. You see? Oh yeah, triangle PQX is similar to the triangle ABC. So PQ over BC, yeah, that's just the corresponding part, the similar triangles. So we want to get the sum of these three ratios. We can't use the normally algebra when we do the sum of the fraction. We will get the common denominator, right? And here, if we use that way, the denominator will be BC times CA times AB, and on the top it will be PQ times CA and AB, and on the second one numerator we will got RS times BC AB. So it will make the problem complicated. So we can use the same denominator, and for example, if we use this one and we try our best to convert this part to the same denominator of BC, and also can convert AB, this fraction ratio, to the denominator of BC. So we can keep this one, don't change it. and convert which one? RS over CA. What we can got? RS over CA. RS over CA, yeah, is for the ratio of this small triangle over triangle ABC. So we want to all of them convert together the same denominator. So we can make RS over AC, we know, equals RX over BC, because we want to gather the same denominator of this one. You see, here is BC. Now we got BC, but RX is not on the BC, right? But we know CRXQ is a parallelogram because this pair of lines, they parallel each other. This pair of sides, they parallel. So this is a parallelogram, and this is also a parallelogram, and here is also the parallelogram. So this side congruent, I mean RX congruent to CQ, then we can convert to CQ over BC. Now we know we almost solved the problem, because you see BC, CQ is just a part of BC, and the PQ is a part of BC. Now the last part will be the same thing, TU over AB. We will convert to this part over this part is the same thing like UX, it equals UX over BC. UX congruent to BP. So now all the problem will be the same denominator, right? Denominator is the same, and the sum of all the numerator, PQ and BP and CQ. So we know all of them, put them together, will be equals 1, right? Plus this one, plus this one. So the first problem solved. Okay, let's try the second one. The second one is about the area, right? And we know A, locus A, represents the area of this small triangle. Let us suppose the triangle ABC area of this is S. So we will got A over S. If we take square root of this, it will equals the corresponding side UX over BC. We can, from the first conclusion, we can convert to which one? BP over BC. We can do the same thing of B over S will equal to QC over BC, and the square root of C over S is equals PQ over BC. We know the sum of this one, we put them together, equals 1. So we will got which one? It means square root A over S plus square root of B over S plus square root of C over S equals 1. So each side we can times square root of S to make it more beautiful, right? So this cancel, because we can distribute, right? So we got a square root of A plus square root of B square root of C equals square root of S. And then we can go ahead. We can get each side, we can square it. So we got square root of A plus square root of B square root of C, then squared equals S. That's the final answer. It's beautiful, right? That's why I love geometry so much. I hope you can enjoy it. The most important idea about this problem, when we meet something is about find in the problem to a lot of parallels, and the problem is about the ratio, about the segments and the area. We can use similar triangle property of that. Yes, I think here is the best point to start. Thank you, guys.